In the previous lectures, we have seen how to minimize DFA, and we have seen a few examples of minimizing DFA. And in those lectures, the method that we used for minimizing the DFA was using a method known as partitioning method. And in this lecture, we will be discussing another method of minimization of DFA called the table filling method, also known as the Myhill-Nerode theorem. So let us see how we can minimize this DFA given here using this table filling method. So before we start off, let us try to understand the steps involved in this process. So these are the steps involved in our table filling method. So let's see. First step is draw a table for all pairs of states PQ. So we'll draw a table and we will make pairs of states. How do we make pairs of states? We will make pairs of every state with every other states. And we will obtain the pairs of states. And after that, the second step is mark all pairs where P belongs to final state and Q does not belong to final state. This means that after you make the pairs in the table, suppose you have a pair called PQ, and you have to check when P is a final state and Q is not a final state. Those kind of pairs, you mark them in the table. So you have to only mark when one of them is a final state and the other one is not a final state. So you don't have to mark when either both of them are final states or both of them are non-final states. In those cases, you don't have to mark them. And then the third step is, if there are any unmarked pairs PQ such that the transition of P on X and transition of Q on X is marked, then mark PQ where X is an input symbol. So after you mark all the pairs in the table, after the second step, in the third step, you have to check if there are any unmarked pairs. And from the unmarked pairs, you have to check if the state P on getting a particular input symbol X and the state Q on getting that particular input symbol X, where do they go? They will go, both of them will go to a certain states, right? So from that pair that you obtain, if it is marked, then you have to mark P and Q. Otherwise, no need to mark it. And repeat this until no more markings can be done. So you have to repeat this process until you find that you cannot make any more new markings. And then the last step is combine all the unmarked pairs and make them as a single state in the minimized DFA. So these are the steps that we have to follow. Don't worry even if it seems a little bit confusing right now, it will become clear to you when we solve this example. So let us do our first step, that is to draw a table for all the pairs of states PQ. So let me make a table here and make the pairs of all the states which I can have in this DFA. So here I have drawn the table for this DFA. So here I have A, B, C, D, E, F because I have states A, B, C, D, E, F. And here also I have A, B, C, D, E, F. And why have I given the rows and columns as A, B, C, D, E, F? That is because I want to make pairs of states. So now we have pairs of each states in this DFA. Now let me check. Suppose I want to check for pair AB, which is the cell for pair AB, AB. This is the cell for AB. But if you look at this cell, this is also AB, right? I am having two cells for AB. Now let me just check for CD. CD, this is CD, and at the same time, this cell, this is also CD. This is also CD. That means I see that in this table I am having multiple cells for each pairs. But I don't want that. I only want one cell for each pair. So what we'll do is we'll divide this table diagonally and we'll remove the upper part. I don't need the upper part. So here I have removed the portion of the table that was not required and we are left with this part. Now let us continue with the second step. Mark all pairs where P is a final state and Q is not a final state. So let us start from this. What is this pair? This is BA. So look at the pair BA. We find that both of them are non-final states. So we don't have to mark them. Now coming to the next one. What is this one? This is CA. Look at the pairs CA. You see that C is a final state and A is a non-final state. So we have to mark CA. CA is marked. And look at this one. What is this? This is CB. C and then B. C is a final state and B is a non-final state. So you have to mark this one also. So whenever you find that one is a final state and the other one is a non-final state, then you have to mark it. So let us look at this one. This is DA. D and A. D is a final state, A is a non-final state. So mark it. And this is DB. D and B. D is final, B is non-final. Mark it. And look at this one. This is DC. D and C, both of them are final states, so you cannot mark it. And then the next one, let's come to this EA. E is a final state, A is a non-final state, so you have to mark it. And come to this EB. E is final, B is non-final, so you have to mark it. And come to this EC. E and C both are final states, so you cannot mark. So come to this. This is ED. E is final, D is also final, so you cannot mark this. And come to this FA. F and A. F is a non-final state, A is also non-final state. Since both are non-final, we cannot mark. And come to this. This is FB. We see that F and B both are non-final states, no need to mark. FC. F is a non-final state, C is a final state. Now we have to mark this. And come to this FD. F and D, non-final, final, so mark it. And then FE. F is a non-final and E is a final state, so we mark it. So now we are done with the second step. Mark all pairs where P is final and Q is non-final state. So we are done with the second step. Now come to the third step. In this third step, it says that if there are any unmarked pairs PQ such that transition of P of X and transition of Q of X is marked, then mark PQ. So what is the meaning of this? How can we do this? Let me show you here. So for this, we will check the pairs which are unmarked from the last step. Which are the pairs which are unmarked? This one, this one, this one, this one, this and this. So let us check the first pair. This pair is BA. So for the pair BA, I'm going to check for pair BA. And how do I have to check? I have to check the transition of B on input. It says on input X, that means any of the inputs. So here we have two inputs, 0 and 1. So B on input 0, where does it go? And A on input 0, where does it go? So let us look at our transition diagram. B on input 0, where does it go? It goes to A. It goes to A. And A on input 0, where does it go? It goes to B. Now we get a pair called AB. Now you have to check in the table if AB is marked. So we look at the table, which is the cell for AB? This one. This is not marked, so we don't have to do anything. Okay. Next, what you have to check is, we have now checked for input 0. Now let's check where does B go on input 1 and where does A go on input 1. So we see that B on input 1 it goes to D and A on input 1 it goes to C. Okay, so let's check this pair DC. Is DC marked in our table? Where is this DC? This is DC. This is also unmarked, so you don't have to do anything. So we have done with this cell. Now come to this cell. This is also unmarked, and see what is this? This is DC. Now let me write it here. For DC, I will check where does D go on getting input 0 and where does C go on in getting input 0. So D on input 0 it goes to E and C also on input 0 it goes to E. Now we are getting a pair called EE, and there is no pair called EE in this table, so you don't have to do anything. Now the next one you have to check where does D and C go on getting input 1. D on input 1, where does it go? And C on input 1, where does it go? So D on input 1 goes to F and C on input 1 also goes to F. So we are getting another pair called FF, and FF is again not present in this table, so you don't have to do anything. So we can leave it. So we have finished this cell for DC. Now let's come to this cell. Now what is this cell? This cell is called EC. This is EC. Now let's check what happens in EC. E on getting input 0, where does it go? And C on input 0, where does it go? E on input 0, it goes to E itself, and C on input 0 also it goes to E. So again you are getting this pair called EE, which is not present in this table, so leave it. And the next one what you have to check is E on input 1, where does it go? And C on input 1, where does it go? So E on input 1 goes to F, and C on input 1 also goes to F. So this is again a pair that is not present in this table, so we can leave it. Now we are done with this cell. Now come to this cell. What pair is this? This is the pair for ED. ED. Now let me check. Where does E go on getting input 0, and where does D go on getting input 0? E on input 0, it goes to E itself, and D on input 0, it comes to E. So now we are getting this pair called EE, and there is no cell called EE in this table, so you can leave it. And then the next one is E on input 1, where does it go? And D on input 1, where does it go? E on input 1 goes to F, and D on input 1 also goes to F. So you are getting another pair called FF, which is again not present in this table, so you can leave it. Now we are done with this. Now let's come to this one. What is this? This is the pair FA. Let me write it here. Pair FA. So we have to check where does F go on input 0, and where does A go on input 0. So where does they go? F on input 0, it goes to F itself, and A on input 0, where does it go? It goes to B. Goes to B. Now you are getting a pair called FB. Now check where is FB. F and B, it is this cell, and it is not marked. So since it is not marked, you cannot do anything right now, but you have one more condition to check, that is where does F go on getting input 1, and where does A go on getting input 1. Now F on input 1, it goes to F itself, and A on input 1, where does it go? It goes to C. Now you get this pair called FC. Now check if FC is marked. Where is FC? FC. Yes, FC is marked. Now we say that FC is marked. Now since we see that FC is marked from this, now you have to mark FA. Now where is FA? This one. So let me mark FA. This is marked now. Okay. Now let us continue. What is left? This is left. And what is this one? This is FB. FB. So let's check where does FB go. F on input 0, where does it go? And B on input 0, where does it go? So F on input 0 goes to F itself, and B on input 0, it goes to A. So I'm getting this pair called FA. Now check if FA is marked or not. FA, yes, this one, this is marked. Now since I found that FA is marked, so I have to mark FB also. So let me mark FB. This is marked. Alright, so this is how you have done. So we have completed the first step. This step 3, we have completed the first iteration. Now you have to continue this. You have to repeat this until no more markings can be done. So you have to continue these steps until you find that no more new markings can be done. So I'll not continue this, because even if you continue it, in the next step you will find that there will be no more new markings. It will be only these markings that we have made that you will get even in the next step. So when you find that in the 2 consecutive steps you are getting the same markings and no new markings can be made, that means it is time to end the process. So here, as I told you, even if you do the next one, you get the same thing. So we end the process and we go to the final step, that is combine all the unmarked pairs and make them a single state in the minimized DFA. So let me combine all the unmarked pairs. So which are the unmarked pairs here? We see that this one, AB is an unmarked pair. So let me write it over here. AB is an unmarked pair. And what is the next one? This one. What is this? This is CD. CD or DC, you can write anything. So let me write DC. And this is the next one. What is this? This is EC. EC. And the next one is this one, which is ED. ED. So these are the unmarked pairs. Now we have to combine them and make them a single state in the minimized DFA. So in order to do that, how do we do this? Let me just copy down the original DFA over here. So here I have my original DFA, and let me just combine these states. We have AB. This is AB. Let me combine AB. Let me just make AB like this. And then next is DC. This is DC. So let me combine D and C. And another one is EC. Where is EC? This is EC. So I'll combine EC. And another one is ED. ED is this one. So I combine ED. So these are my combined DFAs. Now let us try to make the minimized DFA out of this combination that we have made. So AB can be combined into a single state called AB. I'll call it AB. This is a single state. Okay. And since A was my initial state in the original DFA, AB will be my initial state. And then now you look at this, we have states DC, EC, ED. So we see that when we combine them, DC, EC and CD, they are actually all combined together. If you look at these lines I have made, you can see that they are all combined together. So instead of making them three separate states, you can make them a single state. So I will combine E, C and D, and I will make it a combined state. So let me call it CDE. Okay, so CDE, this is a combined state. And also in the original DFA, C, D and E were final states. So here this state will be a final state or accepting state. Okay, and then the remaining one is F. F is the remaining state that we have. Let it be over here. Now A and B, we see that they are having this transition 0 input. So that means A and B on input 0, they go to themselves. Okay, they go to itself on input 0. Now on input 1, where does it go? You can see from this diagram that on input 1 they are going to these combined states. So on input 1, AB will go to CDE. And inside CDE also, if you check, you see that among themselves they are having this input 0. So you can say that CDE, it goes to CDE on getting input 0, and on getting input 1, where does it go? It goes to F. So if you look at this carefully, you can see that D is going to F, C is also going to F, and E is also going to F on getting input 1. So I can say that on getting input 1, they used to go to F, and F stays in F itself in both inputs 0 and 1. So F stays in itself on inputs 0 and 1. So here we have obtained the minimized DFA. So this was our original DFA, which had 1, 2, 3, 4, 5, 6 states. But in our minimized DFA, we have only 3 states. And this is the way you minimize a DFA using the table filling method. It is also known as the Myhill-Nerode theorem. So I hope this was clear to you. Thank you for watching and see you in the next one.